Okay, so we're going to do a few harder questions now. They're a lot more general, which makes them a bit more difficult to approach. So this first question says, show that the diagonals of the rhombus with vertices K, L, M and N that they've given to you bisect each other at right angles. Now, a really good maths teacher of mine once told me it's really important with geometry to draw a diagram. They will often give you one, and we draw on top of it, but in this question they didn't give you anything. You should draw it, and it's important to know how to draw it. So when they give you the points, they give them to you in a cyclic order. They have to be joined in that order. Okay, so we're going to plot the point K, 4, 2, that's that one there. Then when you plot the point L, minus 1, 4, you join K to L. Then when you plot M, 1, minus 1, you join L to M. Then when you plot N, 6 minus 3, you join M to N. So it goes in a cyclic order, so that you know how to join it is in the order that they've given you the points. It's like a join the dots when you were a little child. Okay, so once we've drawn the diagram, you can actually see what the rhombus looks like. They're talking about the diagonals of the rhombus. So I've drawn them in red, just ruled them in. Now they're talking about you showing them that the diagonals bisect each other at right angles. Now people make a real mess of this when they do their proofs in exams. In the HSC it can be done abysmally. If you set your working out well and know what you're doing, you'll get full marks for this and you'll leave a lot of people that have no clue what they're doing. Okay, so we are going to look firstly at the midpoints, okay, because there's two things to prove here. We are proving that we're bisecting and we're proving that they're at right angles. So we're going to take them one at a time. For bisecting, we need to find midpoints. So let's see what happens. We're going to look at one of the diagonals, which is KM, and we're going to find the midpoint of that diagonal. And after that, we're going to find the midpoint of the other diagonal and see what happens. So when we find the midpoint of KM, just take the two points, K and M, put in your X's and Y's where they go, you know the midpoint formula. So just sub them in. I haven't written them up there for you, you should know what you're doing by now. So sub them in, and we end up with a midpoint for KM of 5 over 2 1/2. You don't need to change it to a mixed numeral or anything because we're just trying to prove that things are the same. So, and we're not graphing it. We don't need to put it on a graph. Okay, so midpoint of LN, the other diagonal, here, take the L and the N and find the midpoint of those, and we find that the midpoint of KM and the midpoint of LN are the same point. Okay, so the midpoint of the two of them are the same. So what that actually means is, if the midpoint of that is the midpoint of that, then we've automatically means that this distance must equal this distance, and this distance must equal this distance. So you have proven already that they are bisected. But you write it like this. After you've found the two midpoints, you have to say that those midpoints are the same. So midpoint of KM equals the midpoint of LN. And then you can say, therefore, KM and LN bisect each other. A lot of people on that question, when they see bisect, they think two equal distances and they start trying to find a distance formula. There's no need for it. Just find the midpoints and prove they're the same. Okay, when it says at right angles, the proof for that, think right angles means perpendicular. We know that when we see the word perpendicular, we find gradients. So we're going to be dealing with gradients here. We're going to find the gradients of the two diagonals. With the gradient of Km, I have put these points in differently just because I wanted to. It doesn't matter which one's 0.1 and which one's 0.2 over here. You choose. I've swapped it around here to what I did over there, but it doesn't make any difference to the answer. So when you sub in your points, Km, into the gradient formula with the 2 points in it, we end up with a gradient of 1. Do the same for the other diagonal. We're going to put our L and N in and find the gradient of that diagonal, and we end up with a gradient of -1, which if you look at your diagram makes a little bit of sense. One of them, that would be the one with the positive gradient, and this one would be the one with the negative gradient. So when we look at those two answers, we're going to multiply those two gradients together and see what's going on. When we do that, we get -1. And that is one of the things I told you to learn when we did perpendicular lines. So if you go back to your notes, you'll see that one of the things I told you to learn for perpendicular lines is the gradient of one of the lines times the gradient of the other line equals -1. So once you prove that, you can then say that Km is perpendicular to Ln. You can use that symbol, it is legal to use it. Then you can say, therefore Km and Ln cut at right angles. Okay, so the final answer then is therefore Km and Ln bisect each other at right angles because you've done the two sections of the proof that you need. Okay, so we want to do this properly in the next test, so make sure you do your working like I've just shown you. Alright, the next question. What type of quadrilateral is formed by these points? So as I said before, it's really important to draw your diagram. So I'm going to draw it up, knowing that they've given it to you in a cyclic order. So I'm going to do an H to I, do an I to J, do an J to K, and you'll end up with that. The reason for drawing that diagram is so you get an idea of what's going on and where you're going to start. So it says what type of quadrilateral. Well, you're probably looking at it now going, I think it's a trapezium, because it doesn't look like anything else, and it looks like it might have a pair of parallel sides here. So by drawing the diagram, you can actually see where you should start your working. So we're going to probably start in a minute by looking at those two lines and just see what's going on with those gradients. I'm going to do that on the next video.